Welcome to LMS, Department of Collegiate and Technical Education's Unit 1, Basics of Kinematics, Session number 6, Inversion of Mechanisms, Mechanics of Machines for 3rd semester students. So myself, Venkatesh, lecturer in Mechanical Engineering, Government Polytechnic, Kerpet. As its outcome of this session, to get the knowledge about inversion for 4-bar chain, to get the knowledge about the beam engine, to get the knowledge about coupling rod of locomotives. So in the previous sessions, we already discussed about mechanisms, inversion of mechanisms, types of kinematic chains. So here the mechanisms, here the mechanical member, the set of mechanical member arranged in a specified manner to obtain or produce specified motion, or in a kinematic chain, any one of the link will be fixed. So it gives a relative motion. It gives relative motion. That motion will be completely constrained or incompletely constrained motion. We call it as mechanisms. Here in a 4-bar chain means nothing but consists of 4 links. If we can more than 4 links, we call it as compound mechanism. If the chain it consists only 4 links, we call it as simple mechanisms. So next one, inversion of mechanisms. Here any one of the link will be fixed in a kinematic pair chain. So we obtain mechanisms, but here the different link will be fixed. The different link is fixed to obtain the different mechanisms is known as inverse mechanisms. So here the relative motion between them is remains same, but absolute motion drastically changes in inverse mechanisms. So another one is types of kinematic chains. You know the types of kinematic chains. So here the 4-bar chains. So in a single slider crank chain, double slider crank chain. 4-bar chain consists of 4 turning pair. So there the 4 turning pair. This link will be whether kinematic chain, either the constraint chain or incompletely constraint chain. We can easily find out by using other relationship. You know that. So another one is a single slider chain. Here it nothing but one sliding motion exerted. Another remaining 3 are turning pairs. We call it a single slider crank chain. Double slider crank chain. In a double slider crank chain, 2 sliding pair and 2 turning pair. 2 sliding pair, 2 turning pair. This means we call it as double slider crank mechanisms. Okay, in these sessions I am going to teach about inversion of 4-bar chain of beam engines and our crank and lever mechanisms, coupling rod of locomotives. Yeah, inversion of mechanisms. Here the first one is 4-bar chain or quadratic cycle chain. So 4-bar chain or quadratic cycle chain. Quadratic means 4. Here the figure shows the 4-bar, simple 4-bar kinematic chain. Here the simplest and the basic kinematic chain is nothing but 4-bar chain. So here, it consists of 4 links. Link 1 and link 2, link 3 and link 4. So each of them form a turning pair at A. So at A, at B, C and D. The 4 link may be different length. So here, each link forming a turning pair at A or B respective at the point will be B, C and D. So each having a different length. See here, the link AD, so here we call it as link 4. So link AB call it as link 1, it's a fixed link, or we call it as prime. So link B and C, so we call link 2, that consists of link 2. So link C and D, the link we name it link 3. So AD we call it as link 4. So here, one of the link, so in the AD, so here it will be complete revolving about at the pivot at the point A. So how means you are the satisfying of Grasshoff's law. So Grasshoff's law state that, so here the summation of shortest and longest link length, should not be greater than remaining 2 link length. Means, So here if you considering this is the shortest link length, yes, this is longest link length 1 here, so link 2, so link 3, here the Grashoff's law state that the summation of shortest and longest link length should not be greater than L2 plus remaining two link length. So this is, so here one of the link AD, it is satisfy this law, so it's nothing but we call it as crank. So crank. So here in the turning pair exactly here, so end, so either the rotating either clockwise direction or anti-clockwise directions. So here the link BC, so here the link BC will be oscillated or the turning at the point B, so turning at the point B, so we call it as lever or rocker. There is a connection between link BC and link AD is known as coupler. We known as coupler or connecting rod. We call it as connecting rod. Got it? So in 4-bar chain or quadratic cycle chain is the simplest in a kinematic chain or a simple mechanisms, you know that. So it consists of 4 links, so each link is having a different length, so it exert 4 turning pair. Here one of the shortest link will be revolved at the point A, so here that the point A, so it gives, so the rotary motion transform into rotary motion into oscillatory motion or reciprocating motion or vice versa. So in a Grashoff law state that, so here the summation of shortest and longest link length should not be greater than remaining two link length. So here L2 and L3. Here it's having a different so here the kind of inversion of 4-bar kinematic chain. So here this is the animations how your the crank will complete one rotations. So complete one rotation. Here at the point A you having a turning pair, at the point B having a turning, so here at the point C also turning, at the point D also turning. So therefore 4-bar chain it exists means 4 turning pair. 4 links, so 4 turning pair at A, B, C and D. Got it? Let us move to the here inversion of 4-bar chain. So inversion of 4-bar chain in a kinematic chain. So here the one of the link will be fixed, nothing but we call it as a frame. So here the different link we fixed, we obtaining a different mechanisms. So here the likewise in a case 1 and case 2, case 3 similarly so occurs. So in a Grashoff to satisfy the Grashoff law, different cases, and case 1 and case 2, case 3 likewise LS S1 S plus L1, so likewise equal to L1 plus L2, so likewise, so you getting. So inversion of 4-bar chain, so there are many inversion of the 4-bar chain. At the following are important from the subject point of view. One is beam engine, crank and lever rocker mechanisms. So another one is a coupling rod of a locomotives. So another white engine indicator is also there, but is not there in a subject. So they are in syllabus. So therefore here in a subject point of view, here you only beam engine and coupling rod of locomotives. Let us move to the beam engines. So in a beam engines are crank and lever mechanisms, also called as crank and lever mechanism. In this mechanism, when the crank rotates about the fixed center A, the lever oscillates about the fixed center D. So see here, So you can observe the figure as shown figure. You can have a link, it consists of 4 link. So prime link 1 is called as L prime. So here the link 2, link AB, so we call it as crank 2, link BC, we call it as link 3. So CDE, we call it as lever. So we see CDE is called as lever. So and this will be piston rod. So at the end of the lever, a piston and cylinder rod arrangement, you know that. In this mechanism, when the crank rotates about the fixed center A, when the crank rotates about fixed center about A, means the crank will be pivoted at the point A. So here the rotation take places. So at the end of the E, at the end of the lever oscillate about the fixed center D. The lever, so this is the lever, so will be pivoted at the point D. Lever pivoted at the point D, it is oscillated here at the point D. The end E of the lever CDE connected to the piston rod, which produce, so which reciprocates due to the rotation of the crank. When crank is rotation either clockwise direction, so either anti-clockwise direction, so whether lever will be oscillated at the point pivoted at the point D, so then the piston rod will be to and fro motion take place. So in other words, the purpose of this mechanism is convert to rotary motion into reciprocating motion. So these machines, so here the beam engines are used in controlling of control valve in a high pressure oil and gas pipelines. So you know that in the punchings, so forging, extrusion of a rod and sawing, so etc. So you can observe, so extrusion of rod and beam engine, controlling of controlling valve of high pressure and gas line and pipeline. So using of, so this is the purpose of the beam engine means, so converting of rotary motion into reciprocating motions. So this punching area will be used for different tasks also. Here the piston and cylinder we can use it for in a punching machine, or nothing but a piercing or blankings for operations. So here the animations are the simple model of the beam engines. You can observe here the beam engine is established, so in the 17th centuries. So this is animations of a beam engine. Here the crank pivoted the point or the flywheel, so or the motor. This pivoted the crank will be rotated by, so hand, or nowadays will be rotated by the belt drives or motor. So here the lever will be pivoted at the fixed center, pivoted at the point D. So at the end of the lever, here the piston, so and cylinder arrangement, whether the piston will be moving to and from motion while crank rotation either rotating in clockwise directions. Let us move to the another one, coupling rod of locomotives. So here coupling rod of locomotives. In this mechanism, the link AD and BC having equal length. Here it consists of 2 wheels or 2 flywheels or whatever, 2 wheels. So the 2 wheels will be connected by link BC and link AD. It's having same length, will connected. So both are connected by using crank. So therefore we call it as having equal length. AD and BC act as a crank. We call it as double crank mechanisms. The link CD acts as a coupling rod, and the link AB is fixed in order to maintain a constant center to center distance between them. So here the link AB is a fixed to maintain a constant distance between them. So but link 3, there is a connection between crank BC and AD. So crank BC and AD, there is a coupler, we call it as coupling. So coupling rod of locomotives. Why we call it as coupling rod of locomotives? There is a connection between BC and AD, means BC and AD which are links, sorry, crank. So this crank will be connected by link 3. The link 3 we call it as coupling rod. So there is a coupling between them, so therefore we call it as coupling rod. So here this mechanism is meant for transmitting rotary motion from one wheel to the other wheel. So here the means the purpose of this machine to transmit rotary motion from one wheel to the another wheels. The application of the coupling rod and locomotives, you know that in steam engines of a rail. So in earlier days we are using steam engines. Earlier days using steam engines. So here the coupling rod or the locomotives, we call this coupling rod locomotive, you are using to transmit rotary motions. To reciprocating motion convert into rotary motion. This rotary motion will be again will maintain constant speed, and then constant speed and motion of a wheel. So you can observe, I show one animation. Here the two wheels. So here the crank. So the wheel here is a crank. This is nothing but a frame. So this wheel, the crank will be attached to the wheel. So don't confuse. So when the crank is rotating, the two wheel rotating. So to the link AB, so that but frame fixed. It will maintain a constant distance. Maintain constant distance. Okay, let us move to the some multiple choice question for in this session. The question number 1, a 4-bar chain has your option A, all turning pairs, B, option B, one turning pair and other are sliding pair, option C, one sliding pair and other are turning pairs, option D, all sliding pairs. Here in a 4-bar chain, so you know that 4-bar chain, it consists of 4 links. So 4 links. So your option, all turning pairs, one turning pair and the other are sliding pair, one sliding pair and others are turning pairs. Option D, all sliding pair. Times out. So here 4-bar chain, it consists of 4 links, all are turning pairs. All are turning pairs. So we'll move to the next question. Question number 2. In a single slider 4-bar linkage, when the slider is fixed, it forms a mechanism. It forms a mechanism of in a single slider 4-bar linkage, when the slider is fixed, it forms a mechanisms. Here in a single slider mechanisms, one of the link will be fixed. So here fixed obtaining a different mechanisms. So different mechanism. Your option is hand pump, your option B reciprocating engine, your option C quick return, so your option D oscillating cylinder. It is comes to the inversion of 4-bar mechanisms. Inversion of, so here the 4-bar single slider mechanism as single slider mechanisms. Times out. So nothing but your answer is hand pump. Your answer is hand pump or bore well. Bore well. So in your villages, so nothing is the example for hand pump. Your option 3, sorry, question number 3, beam engine is also called as your option A, double crank mechanisms, double lever mechanisms, option C, crank and lever mechanisms, so option D, none of the above. None of the above. So we can memorize the previous slide. I am explaining the beam engine. So beam engine is the purpose to convert rotary motion into reciprocating motion. It is the applications of beam engines or the extrusion of steel rod, extrusion of rod or sawing or nothing but a controlling of inlet valve, means control valve in high pressure and gas pipeline and fluid oil pipeline and punching and piercing etc. So beam engine is also called as crank and lever mechanisms. Crank and lever mechanisms. Okay, let us move to the question number 4. Here the coupling rod of locomotive is a your option A, double crank mechanisms, double lever mechanisms. So mean your option C, crank and lever mechanisms. Your option D, none of the above. Once again, question number 4, coupling rod of locomotive is a double crank mechanisms, double lever mechanisms, crank and lever mechanism, none of the above. None of the above. Times out. Here the coupling rod locomotives. Here 2 crank, so you know that it is connected by the one rod, nothing but we call it as coupler. There is a coupling, so we call it as a double crank mechanisms. Here the double crank mechanisms. Our answer A is the right answer, because you know that here using 2 crank. So 2 crank to purpose to drive give rotary motion to one wheel to the another wheel. So we call it as double crank mechanisms. Question number 5. Example for 4-bar chain is your option A, pendulum pump. So your option B, coupling rod of locomotive. So your option C, rotary internal combustion engines. Your option D, all of these. Example for 4-bar chain. So example for 4-bar chain. So here everyone also consists of 4 links, but what means 4-bar chain? So here 4 turning pair exerted. 4 turning, so here nothing but, so here the coupling rod of locomotives. Coupling rod of locomotives is the right answer. Question number 6. In a 4-bar chain or quadratic cycle chain, your option A, each of the 4 pair is a turning pair. Or option B, 1 is turning pair and 3 are sliding pair. And option C, 2 are turning pair and 2 are sliding pair. So option D, 3 are turning pair and 1 is sliding pair. So in a 4-bar chain or quadratic cycle chain, option each of the 4 pair is turning pair. 4-bar chain, each of the 4 pair is turning pair, 1 is turning pair and 3 are sliding pair. So 2 are turning pair and 2 are sliding pair, we call it as sliding pair, double slider. 3 are turning pair and 1 is sliding pair, we call it as single slider crank mechanism. 1 is turning pair and 3 are sliding pair. So here it's not like that. So 1 turning pair and 3 sliding pair. So but each of the 4 pair is turning pair. This is the right answer. Here the single slider mechanisms. Question number 7. The kinematic chain consists of 4 turning pairs. 4 turning pair is called your option A, single slider crank chain. Your option B, double slider crank chain. Your option C, 4-bar chain. Your option D, none of the above. Question number 7. The kinematic chain consists of 4 turning pair. 4 turning pair, single slider crank chain, double slider crank chain, 4-bar chain, none of the above. So in a single slider crank chain, 1 sliding, 3 turning pair. In a double slider crank chain, here are 2 sliding and 2 turning. So now in a 4-bar chain, all are turning pair. All are turning pair. So therefore your right answer is the option C. Option C. Question number 8. Question number 8. So here the beam engine is an inversion of. The beam engine is an inversion of your option A, single slider crank chain. Your option B, 4-bar chain. Your option C, double slider crank chain. Double slider crank chain. Option D, none of the above. None of the above. So here beam engine is an inversion of. So you know that single slider crank chain, 4-bar chain, double slider crank chain, none of the above. None of the above. Okay, single slider crank chain is not comes under this one. So here the 4-bar chain. Your option is 4-bar chain. So inversion of 4-bar chain. The first one is beam engine. So therefore, so engine indicator, beam engine, locomotives. So locomotives, we call it as the inversion of 4-bar chain. Inversion of 4-bar chain. Question number 9. What straight line mechanism is also called as option A, double crank mechanisms, double lever mechanisms. Your option C, crank and lever mechanisms. Your option D, none of the above. None of the above. None of the above. Here what straight line mechanism is also called as option A, double crank mechanisms. Your option B, double lever mechanisms. Option C, crank and lever mechanisms. None of the above. In a 4-bar mechanisms, inversion of 4-bar mechanisms, beam engine and what straight line mechanisms and also coupling rod of locomotives. So all ours comes under 4-bar mechanism. So therefore your option C is the crank and lever mechanisms. Crank and lever mechanisms. The last question of this session. All the 4 pairs are turning pair in. All the 4 pairs are turning pair in your option A, 4-bar chain, single slider crank chain. Option C, double slider crank chain. Option D, none of the above. None of the above. Here all the 4 pair are turning pairs. All the 4 pairs are turning pair. So here the 4-bar chain, single slider crank chain, double slider crank chain, none of the above. Your option double slider crank chain, here 2 sliding, 2 turning. Single slider means only single sliding, 3 remaining 3 are turning. But whereas in 4-bar chain all pairs are turning pair. So therefore your answer is option A is the right answer. Okay, you refer following the links to get the information. So here the R.S. Kurmi is the textbook of theory of machines. So in PDF another textbook is there, R.S. Ratan. So here another you will go for the social media www. So make diploma.com. So here the engine Wikipedia, organization Wikipedia. So here the you go for Google's search engines etc. to get the plenty of so informations. Any questions? And thank you all. So these are our team members. MS Devraj sir, Chairman GPT Harpanahalli, TS Chandrasekhar sir, Moderator GPT Tumkur, Vinod Kumar sir, Subject Expert GPT Nagamangala, Nagraj sir, Subject Expert Srimati LV Polytechnic Asan, Aravind Rangadal sir, Subject Expert GPT Kalaburgi, Venkatesh myself content developer GPT Kerpete, Ramya madam content developer GPT Ramanagara, Devraj D content developer KPT Mangaluru, so Nemichand, so content developer GPT Turvekere, Ravi Prakash sir content developer GPT Sira, Lakshmi Narayan sir, so the content developer GPT Chikamangaluru. Once again, thank you one and all.